Hey guys, welcome to this video of nested cross validation. So we have heard about cross validation. It's a technique in machine learning that helps you reduce overfitting, that helps you balance the unbiased data. And in this video we will be talking about nested cross validation, which is kind of a little advanced technique, and it helps you a lot when in case your data is overfitting, right? So don't worry, I'll first cover cross validation in just kind of a revision of cross validation, and then it will be easier for us to understand nested cross validation once we have revised cross validation. So cross validation is a technique in machine learning, and what we do in cross validation is, let's say I have my training data, right? So cross validation generally has a parameter called k, so it will be called k-fold cross validation, right? So k-fold cross validation means if I am doing 5-fold cross validation or 3-fold cross validation, so basically the value of k becomes equal to 3 or 5. Okay, so in this case, let's say I am doing a 3-fold cross validation. So 3-fold cross validation will mean that I divide my training data, divide my whole data into 3 parts. I divide my whole data into 3 parts. Remember, we are just seeing cross validation, right? And then later we'll see nested cross validation. So this is cross validation. So I divide my data into 3 parts, and then what I'll do, I'll decide, okay, take 3 steps, or just iterate over the data 3 times, and iterate in this fashion where you take k minus 1 part as training set and 1 part as a test set. What does this mean? This means that if I am doing a 3-fold cross validation, I will be choosing 2 parts initially. Let's say I choose this part as a training set and this part as a test set. Okay, training set, test set. Now I'll train my data on this, I'll test my data on this data, this part, and then I'll give my result. Let's say I'm aiming for accuracy of my model, so I'll report my accuracy. Let's say accuracy for fold 1 was let's say A1. Okay, now similarly for fold 2, what I'll do, for fold 2 I'll just select the other 2 parts, and then the remaining part will be test. So for the other fold 2 part, what will happen, this will become my training data, and let's say in this case this becomes my test data. Okay, this is for fold 2, right? Again I'll train my data on my training data, and then I'll test my model on this test data, and I'll get A2, right? Similarly I'll get A3 as well, and then once I'll get all these accuracies, I'll just do a mean of it. So A1 plus A2 plus A3 divided by 3, right? This becomes your accuracy of your model. So the advantage of this is that if there is something that is missing out, just think it like this: if there is something that is missing out on this particular set of data, a pattern, and let's say you would have put this data into test data. Okay, let's say you are just going for you are just training it without cross validation, and you selected these 2 parts as your training data, and there was some important pattern or important pieces of data that could have contributed in your model, but they left behind in the test data. So in this case, cross validation helps you to gather that pattern as well, along with keeping an unseen data, right? So this is the advantage of cross validation, that you can cover all the trends in the data. You don't leave any trends or any insight that was there in the test data and you missed it out because you wanted to keep some data for testing. So that is the advantage of cross validation. This is what cross validation is. Now let's move towards nested cross validation, which is the topic of this video. So nested cross validation is a bit different, and it's a bit interesting as well. So nested cross validation says ki, hey, when you are you understood the advantage of cross validation, right? So nested cross validation says that if you have understood the advantage of cross validation, and let's say you have understood this point, that it helps us reduce overfitting because it's generalizing the data more instead of memorizing it. It's understanding more patterns instead of focusing on one pattern. That is what generalizing means. So why not, when you are training individual models, why not you put cross validation in them as well, right? Remember, when we were training 1-fold of this model, what we were saying, okay, let me take this much of a data as my training data, I'll train my model on this data, and then I'll test it on it, and I'll put the score as A1, right? Now nested cross validation says that hey, if you are making 3 parts of your data and in your fold 1 you are using this part as training and this part as test. Okay, so if you're using it like this way, why not you do this this particular approach where you put cross validation inside this training as well. So you are doing an outer cross validation as well, and then inside for each fold you are doing cross validation again, right? That is why it become nested, right? You can relate this example, guys, to nested for loops or nested loops, any nested loops where you have a loop and inside that loop you have a loop, right? So for example, if I just take example of nested loop, so if I have for I in range of 1 2 3, right, and then inside this I have for j in range of 2, right? So what will happen here, for I in range of this, and if I print ij, so for each value of I, j will get print, right? So if I is equal to 1 initially, we will have 0 and 1, and for j will becomes 1, right? So 1 1, and then for value of I will be 2, right? So for each value of I you will have value of j. This is what nested loops are. Similarly, you have nested cross validation here. Now, so what happens, this outer loop is there where you are having your simple cross validation, and then for individual fold of that cross validation you are again doing a cross validation, right? So it becomes nested, and we call the inner one as inner loop, simple name, right? We call the inner one as inner loop. And what will happen in this inner loop is let's say I was doing 3-fold cross validation in outer loop, I can do a 5-fold cross validation in an inner loop. Okay, so what I'll do a 5-fold cross validation in an inner loop. So this training data got expanded here, okay, in 5 folds. This whole 2 pieces of data got expanded here in 5 pieces, and again we are doing simple cross validation here. First we'll take these 4 data, train it on them and test it on this, then we'll take these 4 data, train it on them, test it on this one, right? Similar way of cross validation. The advantage of this is that when you have this model here, the F1, the fold 1 model, remember in the outer loop we were having 3-fold cross validation. So when you had this outer loop thing there, so now the model that you are having is highly optimized, and it will be tested again this test model as well. So you are working hard in case to reduce the overfitting and to make your model more unbiased towards the less occurring data or less occurring trend. Now this was the technical part. Now let's see a more simple example of it. I'll just see a general analogy that you can, it will be easier for you to understand. Imagine this is a restaurant, okay? Imagine I am a restaurant owner, I'm a chef of a restaurant, okay? I'm not an owner, I'm a chef of a restaurant, and there's a expert panel of chefs that are coming in my restaurant today, right? So what I'll do is I'll ask some of my friends. This is me, okay? This is experts, and these are my friends, okay? These are my friends. So what I'll do, I'll ask some of my friends ki, hey, I am preparing some dishes, can you test those dishes for me and just give me some feedbacks, right? So I'll ask them to try out my dishes and they'll give me some honest feedback, and I'll use that feedback to prepare a new recipe, or optimize my recipe, and then I'll present my dish to the chefs. Instead of, remember guys, I am not doing this that okay, I am presenting something to my friends and then I am taking the same thing to the chef if it works fine. No, I am learning from that thing, I am adapting some changes, or in machine learning term you can say I am learning some parameters there, and then I am using those parameters to optimize my outer loop cross validation, and then that thing is going to my experts, or basically the outer test set. Okay, so this is a simple analogy of the same thing that we discussed, nested cross validation. So now what we can do is before going to the demo part, I just have prepared some code for it. I'll just have an announcement. So I am launching my own data science course on Grow Test Skills, and where I'll be teaching. It's a 3-month course. We have tried to keep it short and on point. Like we don't include Python in that. Reason being that we put Python as a prerequisite, because and there's a source of prerequisite to learn that Python as well. I'll provide all the details of the course of Python and data science in the description of this video. But the announcement was that I'm coming with my own data science course. If you like this series of videos, if you like my teaching, if you like my teaching style, and if you love data science, do check the course out. The link of the course is in the description. Currently there's an early bird discount going on, so you can avail that. Okay, back to the video. Now let's just go towards a quick demo, right? So what we have here is, let me just keep this pen apart. Okay, what we have here is simple mushroom classification, and it's just a simple data set I just pulled off. And the main reason or the main target that I have from this was to explore how to implement nested cross validation. So just after removing the null values, and after just doing one hot on coding for the categorical data, you can learn about all those things in my class, guys, where I'll be teaching you how to handle categorical data, what are different types of variable. We will be covering statistics from scratch, we will be covering machine learning, we will be covering mathematics, the calculus part of machine learning, deep learning, and we will also talk about OpenAI and LLM models in a bonus section. So yeah, so once we are done with all these things, we'll just pull our data into different X and Y category, divide our data into train and test set, use a logistic model. Simple. Why I'm using a logistic model? Because I just wanted to test it out. How do you implement nested cross validation, right? We are not going into details of different models here. That let's leave that to a different class. Then you have your parameter grid, and see this, guys. I have inner cross validation model, which is your stratified k-fold. Stratified means that in all the pieces, in all the folds, the ratio of the data. This is a binary classification. So ratio of both the classes would be same, right? So all of your model will have that class imbalance thing managed in them. And I am having 5 splits here. So inner CV is 5 splits. So I am doing a 5-fold cross validation in my inner loop, and then I am doing a grid search there. Grid search is just for finding the right parameter. Remember, guys, I told you that in the inner circle I'll prepare some dishes. I'll present those dishes to my friends, and they'll give me some honest feedback, and I'll be using that feedback to prepare some dishes for the clients. So I can try out different things when I'm presenting dishes to my friends, and that is what parameter grid is doing. Okay, that is what grid search is allowing us to do. Sorry. Now you have outer cross validation, that also takes 5. We can change this and split 5 and plus 4, and have a nested score, right? And nested score would be just average score of that finally that you're getting for your complete model, not inner loop, not outer loop, for the complete cross validation model. So yeah, that was a simple implementation of k-fold cross validation. Again, I don't focus on code that much, because you could have seen this code from any place else as well. But the theory is important, the concept is important, that what is the advantage that we're having. Again, let me just quickly summarize it once. So in simple cross validation, we divide our data into different splits, and we train on one, let's say we are doing k folds, we will train on k minus 1 data, and we'll leave one data apart for just testing of model. So this way we can train multiple models and then take an output of it as an average. That is your cross validation. Nested cross validation allows you to, when you are training the individual parts of a model, inside that also put cross validation. And what will the advantage of that? Advantage of that will be that you can counter the overfitting even more, and also you can remove the biasness from your model. That is the advantage of nested cross validation. Remember, guys, if you're facing a problem of overfitting in one of your algorithms, do try cross validation, nested cross validation. I tried it out and it solved me a big problem. That is why I just thought it will be a good topic to discuss in a specific video. So yeah, my name is Shubhankit. I'm currently working as a machine learning engineer, and I've been in the field of data science for last 4 years. And yeah, I create content over LinkedIn. You can check the details in the description of the video. And yeah, happy learning.